Greetings and welcome, friends. Mr. Waddy and my algebra buddies are here. Everyone here today is writing down corrections for the homework when they need to. This is wonderful. And we yesterday, Ben, you and I, we were literally together yesterday solving literal equations. Literally, we were solving literal equations yesterday. It was pretty wonderful. And solving a literal equation is the same as rewriting formulas in terms of one of their variables. So a literal equation is when I have, Jacob, you're ready to write this down. Here we go. It's when I have more than one variable in an equation. And as a result, unless I have more clues, Jacob, I won't be able to solve for the particular number that my first variable I'm solving for is equal to. The best I can do is rewrite it in terms of the other variable. So here it says solve the literal equation for y. So here's why. I'm going to pretend that x is just a number. I'm just pretending that this is some number. So this would be like negative 18 times 2 or something. Or you could pretend it's negative 180 if you wanted to think about it like that or something. But it's problem 5 on the homework at the end of the packet. You should have found it like yesterday. So let's solve for y. So I've got it's being multiplied by 2 and subtracted by 18x, which this is just a number. What should I do first to get y by itself? I'm going to add 18x to both sides. Notice these two things are not like terms, so I can't combine them. However, guys, we didn't do well enough to distract ourselves and our peers today. And even if we did great yesterday, we still don't have a right to intrude on the rights of other people's education. So here we go, follow along. So 2y is equal to, I'm going to write the x term in front of the constant because that's a cool thing we mathematicians tend to do like that. But I mean, technically, negative 26 plus 18x is the same thing. All right, so you guys writing this down. What's my next move to get y by itself? Yeah, it's being multiplied by 2, so the inverse operation is to divide by 2, and I'll divide everybody by 2. So y equals 9x minus 13 will be the answer to this problem. I've got it. Yeah. So all right, here's question 10. Same objective. I'm trying to get y by itself. Well, why aren't you guys like, come on. I think you're distracting yourselves. Next time I'm leaving you. Well, we're doing 5. So that's why I go over a selection of the problems that represent the entire batch. So learn from the ones I show you and then go back and try the other ones. I might have even done 4 in the video last year. So you could have watched the video from some of the, Ben, be quiet. You could have watched some of the videos from last year while you were doing your homework to get an idea of how to do each problem. Right, that's the plan. So here's question 10. To get this y by itself, I'm going to pretend x is, hey, there's 2 x's here, literally and figuratively, I guess. Literally and literally, kind of. I'm going to pretend those x's are just numbers. So to get y by itself, what could I do to both sides? I want to get everything away from it. I'm going to add 2x to both sides. And behold, this time, there's a like term for it. So I'm going to add 2x right here. Why not? Those are buddies. They're buds. 16x plus 2x is how many x's? Yeah. Excellent. No, we're working on 10 right now. Don't worry about that. That's not helpful. So let's see. Now what do I do? Yeah, you were raising your hand. Yeah, y is being multiplied by 9. So the inverse operation would be division by 9. Right. I'm not sure what you're saying. Yep. Well, these are already far away from y. My goal, notice, is what I obtained at the end, which is a y all by itself on its own side of the equal sign. So that's why I had to get rid of this 9 and this negative 2x, and I started with the negative 2x. Excellent. All right, here we go. This is a classic problem. This problem has probably been given to algebra students for generations. Area of a trapezoid formula. In case you're wondering what a trapezoid is. Like a square plus a triangle. It's a four-sided, two-dimensional figure with exactly one pair of parallel sides. So there's a trapezoid. And the dimensions I need to find the area of a trapezoid, I need a few of them. I need its height, h, and I need its bases, which I would call this base 1 and that base 2. No, I don't, unless I'm looking for perimeter, I wouldn't need these two sides. But for area, the formula, I'll write it larger here. 1/2 the height times the sum of the bases. Okay, so let's solve for B2. So I'm going to pretend that B1 and H and capital A, I'm going to pretend that all of those are just numbers. All right, that's what we do. That's what we do. So, man, I could, as my first move, choose to distribute, but I kind of don't like that idea. I'm not feeling it. How could I get rid of this multiply by a half? I could, and we talked yesterday, I think, about another way to deal with that, because dividing by a fraction is kind of weird. You guys know another way? What's the same as? Yeah, bam, represent. Multiply both sides by the reciprocal. Reciprocal. But when you're doing math on the street, you can call it a reciprocal. Yeah, you can. So notice these 2's cancel out those 1's. They were going to turn invisible anyway. So I'm going to have 2a is equal to h times b1 plus b2. I've heard some British folk call it h. Correct. That's a 2 there, yeah. So now what could I do to get rid of the h? I could distribute, or yeah, I'm going to go the divide route. Technically, I could have done these 2 steps together. You could have actually multiplied both sides by 2 over h if you wanted. But we'll divide both sides by h. So I'm going to have 2a over h equals, hey, notice what happens here. Lovely. Those h's swipe. I get equals b1 plus b2. And look at b2's starting to get lonely. It's only got one friend left. How do I get rid of the b1 here? No, those aren't like terms. No, it's positive. It's being added with. So I've got to subtract b1 from both sides. Now these aren't like terms, obviously, but I'll call that 2a over h minus b1 equals b2. Okay, so b1 and b2 are, sometimes it's helpful to give variable names the same letter, but maybe I have a whole bunch of them. So these are 2, I could have called this a and b, or x and y. Those are definitely not the same b that they're referring to. It's b sub 1, b sub 2. Sometimes we'll even see a list of like x1 and x2 and x3, etc., all the way to x sub n. We'll be able to like name variables, little subcomponents, if I happen to like using the same letter repeatedly. So these are not like terms, which is I think what was being brought up there. So B2, I'll swap it around here, is equal to 2a over h minus B1. My last step was just flipping it over the equal sign. Yeah. Well, actually, you're not writing it right now, so you're not going to make me a liar. But that's what you would write down if you were writing it down. So notice my goal. There's multiple ways of writing it. You also could have written this as 2a minus hb1 all over h. That's another way it could have been entered. But I happen to like this one here for the moment. Let's look at one more problem. 30. Mm-hmm. Average acceleration for an object. Here we go. Oh, here's some more sub-variable names. So you guys got question 30 lined up. So the acceleration, average acceleration, is velocity 1 minus the velocity sub 0. That's initial velocity. Sometimes people even pronounce that V naught. Naught. Nope, V, not Y. I'm just kidding. I think probably that's also a British thing. Maybe 0 is called naught. Oh, actually, yeah. Tic-tac-toe is called noughts and crosses in some other nations, yeah. So it's probably a reference to that. Also, someone once asked, notice tic-tac-toe, there's 3 things, but in tic-tac-toe, you only have X's or O's to play with. So someone was speculating, what if like the toe was like this super power move that you could do that counted as both an X and an O, or like would clear the board? I don't know. Tic-tac-toe. You're only doing tic-tacs. I don't know. But anyways, V1 minus V0 or V sub 0 or all divided by T. Oh, I got a toe when I get 3 in a row, you think? All right. So I want to solve for V sub 1. This problem's tricky, friends. What are your guys' thoughts? How could I solve this for V sub 1? I'm going to do this 2 different ways. I like the idea it's all being divided by t, so I like your first move, Jake. I'm going to multiply both sides by ta, t, ta, ta. Ta is equal to, notice what happens here, the t's cancel out, and I'll have v sub 1 minus v sub 0. Ooh, guys, we're getting warmer. I'm trying to get v sub 1 by itself. How do I get rid of this v naught? V sub 0, add it to both sides. Here's a joke. Get over here, v sub 0. That's all right. Some people will add a comment below. And look, I've got v sub 1 by itself. I'll just flip this around, and I'll have ta plus v sub 0. Now, I did say I could have done this slightly differently. What I could have done as my first move was broken up this fraction. You don't have to write this one down. This is, I think, a less typical way I would have done it. So if I break up the denominator so that it's under each of the terms there, that is a legal move. And now what would I have done to get v sub 1 by itself? Yeah, I would have added v naught divided by t to both sides. Yeah. So I'd have a plus v naught divided by t equals v sub 1 divided by t. Right? And yeah, it's being divided, so the inverse operation would multiply. But I'd have to be careful. I'd have to multiply this entire side by t. Beware, my friend. And so then I'd have to distribute that to both of them. And I'll have t times a is ta. plus, what's t times this? Yeah, the t's would cancel out, right? And I would have v sub 0 equals v1 because the t's over here canceled out. So notice I do in fact get the same thing. It's a slightly different way you could have done it, but I wouldn't usually have done it that way. Well, all right. Thanks for watching, mis amigos. Adios.